All right, our last type of transformational geometry is going to be a reflection. And a reflection, in kind of common layman terms, we would call a flip. So you think about your reflection in a mirror, or if you look at like glass or on water, that is still a reflection. We're going to use the same word here. Now our line that we're going to flip over is called a line of reflection. So up here you can see my line of reflection is right here. I'm going to use the same notation that I did before for my pre-image. So my pre-image there, P, and my image would be the P with the apostrophe mark there, the P prime. Now we already looked at lines of symmetry before in the class, and lines of symmetry are a type of reflection. So you're going to see some of those same concepts coming back. We're just going to kind of talk about them in a slightly different way. For some students, it's kind of confusing because it's almost the same, which is different terminology. For other people, they really like it because it wraps together some things that we already looked at. Now, as far as like algebraically, I have some like formulas to help remember, or some people can visually look at this. It doesn't really matter to me. Just remember that not everyone's the same. Some people can just see it and they know what the answer is. Other people are going to need like a formula to work through it. So as I work through my problems, I'm going to kind of do it visually down here and algebraically up here. So let's just say I'm going to start with a point 3, 2. So we'll say this was given to us. So this point right here is the point 3, 2. Just graphing it like we did old school back in, even elementary school graphing on a coordinate plane, just a plane point. Now I'm going to start with the x-axis because that's what I have first up there in the notes. So this is going to be my x-axis here. So just a reminder, I'll highlight it here. Here is my x-axis, going right through there. So if I'm going to reflect, or you can think about it being that line of symmetry across this line, that's like folding the paper over here, folding along this line. And if you're kind of a hands-on person, you really need to, you can take a piece of paper and fold it down to get there. And that keyword down, that means the one that's going to change, instead of being up here, it's going to be down below. And this is my reflection line. So I went up 1, 2. Now I'm going to go down 1, 2. So this is going to be my point. So my new point, my image, is going to have a -2 instead of a +2, which leads me to our rule kind of up here. So we started with the point x, y. And, oops. The rule says I'm going to keep x, but my y value is going to change from positive to negative. So I'm going to change the sign of the y value. Now I'm going to come through and I'm going to do the same thing, but I'm going to do it for the y-axis. And if you're somebody that really likes patterns or has a good idea about symmetry, you might can go ahead and guess what's going to happen. I'll keep my same point just so we can kind of have some consistency. So I'm going to start with that point 3, 2. This is my pre-image. And the y-axis is this guy right here. So that's my y-axis. So I'm folding now along that line. So I'm folding over. So instead of being on the right, I'm going to be over on the left. And I was 1, 2, 3 to the right. So 1, 2, 3. We have to be even. It's going to be the same on both sides because this is symmetry. So this point is going to be, it's on the left, so it's going to be -3. Oop, that's not a very good looking 3. -3, 2. Notice only the x value changed because I went over from the positive side of my graph to the negative. So my rule for this one would be I'd start with x, y again. But then that would change, that would become -x, y. What was on the right became on the left, or vice versa. Now I know where to put it visually because I'm just counting. I'm seeing how far from my reflection line to the point. So 1 jump, 2 jump, 3 jumps. Remember to count jumps. 1 jump, 2 jump, 3 jumps. Now the line y = x, is a little bit harder to visually see, but easier to do algebraically. Oh, I'll change colors. So this is the line y equals x. So the line y equals x, you got to remember like way back in algebra class. I'm going to draw myself a few little dots here to get my line going, because I'm not a very good drawer. It's going to go through this point like this. Cuts the graph, basically folds it from corner to corner. That's the line y equals x. Now we're going to do exactly what this one says. So my point, which was 3, 2, the y is going to become x and x is going to become y. We basically just switch them. We switch their places because y is x. So that's going to become 2, 1, 2, 3. So it's going to be up here. It's going to be the point 2, 3. It's going to be my image. So I'll come write that rule up here. I like this one since it like is what it says. So I just switch. X becomes y, y becomes x. I switch places. Now the origin takes the x and the y-axis. It's like folding it 2 times. You fold it down and you fold it over. So last color here. Our origin. That's doing a double fold. So that would be folding it along the y-axis and the x-axis. It doesn't matter which one you do first. They're going to be the same fold here. So I'll keep that same point. No reason to change at this point in the example. So I've got to bring it over here to get a negative x and down here to get a negative y. So it's going to become -3, -2. Both of them are going to get treated to the negative sign. So this one, the origin, they're across from each other, so we can kind of visually see that they are across from each other. So through the origin, algebraically, I'm going to start with that x, y. They're still in the same spots, but all I did was change the sign of them.